Hi, the name of this Blender video tutorial is LockedTrackConstraint. One of Blender's tracking constraints is named LockedTrack. The LockedTrack constraint allows one object to point to the negative or positive X, Y, or Z axis of another object while maintaining a selected locked axis. It is, in practice, much like the Track2 constraint, only locking a selected positive axis rather than having a positive axis point upward. To demonstrate the LockedTrack constraint, and perhaps make its function more understandable, I've modeled a simple piston-driven DriveTrain assembly in my Blender scene. The DriveTrain consists of 7 objects: a piston case object, and a piston rod that moves in and out of the piston case, a wheel object, and in this case it's a locomotive train wheel, and a crank object that attaches to the wheel and provides an offset attachment. Between the piston rod and the crank is a connecting rod object that transfers the location movement of the piston rod to the rotation movement of the crank wheel. The connecting rod is connected on one end to the crank object via the crank pin object, and connected to the piston rod on the other end by a linking pin object. Currently, all the objects have their object origins set to the center of their geometry. In real life, the piston would move in and out of the piston case, transferring force to the connecting rod, which in turn would drive the crank and wheel into a circular rotation movement. Our constraints will actually reverse this sequence. I'll begin by creating a control empty object. This is not a requirement for constraining the drivetrain like this, but it provides a convenient control mechanism. I'll place my 3D cursor somewhere below the wheel object and press Shift-A and add an empty object. I will name this object Control Empty. I'll then select the wheel object, go to the constraint editor, and add a copy rotation constraint. In the target box, I'll select the Control Empty object. I want the wheel object to only copy the Control Empty's Y rotation, so I will uncheck the X and Z copy rotation boxes. Now if I select the Control Empty and rotate it on its Y axis, the wheel object follows along with that rotation. Next I will select the crank pin object and add the crank object to the selection, and then add the wheel object to the selection. I'll then press Ctrl-P, and I'll make the wheel object a parent of both the crank and the crank pin objects. Now if I select the Control Empty and rotate it about its Y-axis, the wheel object, the crank object, and the crank pin object follows along with that rotation. Next, on the other end of the drive chain, I'll select the linking pin and then add the piston rod object to the selection. I'll then press Ctrl-P and make the piston rod a parent of the linking pin object. Now if I select the piston rod object and move it along its x-axis, the linking pin follows that movement. Next, I want to limit the piston rod so that it moves only along the x-axis, and I want to limit its movement to the same x-direction movement as the crank pin. That is, the piston rod object should move in the minus x direction the same amount as the crank pin moves in the minus x direction. To do this, I'll select the piston rod object, go to the constraint editor, and add a child of constraint. In the target box, I'll select the crank pin object. I will uncheck the rotation and scale checkboxes, and uncheck the Y and Z location checkboxes. I'll then press the Set Inverse button, which will move the piston rod back to its original position. To see this constraint relationship, I will for now hide the connecting rod object. Now if I select the Control Empty and rotate it about its Y-axis, the wheel, crank, and crank pin objects follow along with that rotation, and the linking pin, which is a child of the piston rod, and the piston rod respond by moving along the x-axis. I will unhide the connecting rod object. Next, we need to add the connecting rod object to the DriveTrain constraint movement. First, I'll select the crank pin object, and then press Shift-S or snap, and snap my 3D cursor to the selected. This places my 3D cursor at the object origin for the crank pin object. I'll then select the connecting rod object and press the origin button in the left tool panel and set the origin to the 3D cursor. Now the origin point of the connecting rod object is located at the same X, Y, and Z location as the crank pin object. With the connecting rod still selected, I'll go to the constraint panel and add a child of constraint. In the target box, I'll select the crank pin object. I'll then press the Set Inverse button, which will return the connecting rod back to its original position. Now if I select the control empty and rotate it about its y-axis, the wheel, crank pin, and connecting rod objects follows along with that rotation. And the linking pin and piston rod respond by moving along the x-axis. The last constraint challenge here is to get the other end of the connecting rod to follow the movement of the linking pin. We can do this by using the locked track constraint. But before I add the locked track constraint, I'll go to wireframe mode, and then turn off my 3D transform widget, and I'll zoom in a bit on the connecting rod object. I'll go to the Object Data Editor, and in the Display panel, turn on the Display Axis. Note that the origin point for the connecting rod object is located at the same X, Y, and Z location as the crank pin object, of which it is a child object. Also notice that in the construction of this object, the positive Z-axis is pointing to the linking pin object to the right, and the connecting rod's positive X-axis is pointing downward, and the positive Y-axis is pointing out towards the global Y direction. This is the axis relationship when any primitive cylinder object is added to a scene and rotated 90 degrees around the Y-axis. I'll go back to shading mode, and I'll turn off the display axis, and I'll turn back on my 3D transform widget. With the connecting rod object still selected, I'll go to the constraint editor and add a second constraint. I'll select the locked track constraint. In the target box, I'll select the linking pin object. In the two selection controls, I'll select the Z-axis. That is, I want the Z-axis of the connecting rod to point to the linking pin's object origin. In the lock selection controls, I'll select the Y-axis. That is, I want the connecting rod's Y-axis to be locked, always pointing toward the global Y-axis. Now, if I select the control empty and rotate it about its Y-axis, the wheel, crank pin, and connecting rod objects follow along with that rotation. And the linking pin and piston rod respond by moving along the X-axis. But now the connecting rod points to the linking pin's origin while maintaining a locked axis, thus always tracking the linking pin's object origin. I'll set the animation length to 100 frames. I'll then go to frame number 1. I'll select the control empty and press the I key and add a rotation keyframe on frame number 1. I'll then go to frame 100. I'll set the Y rotation for the control empty to 720 degrees and then insert a keyframe on frame 100. I'll go to the graph editor, and with the control empty Y rotation curve selected, I'll press the V key and make the rotation curve a vector or straight curve. I'll then go back to the 3D editor and then play the animation.